All right, so this is part 2 of the Chapter 3 test review. Guys, this is where you need to know your identities, in particular, the Pythagorean identities. We've used sine squared plus cosine squared equals 1 a lot. These two at the bottom we haven't used as much, but they will show up every so often, so you do need to be aware of them. So let's start with number 16. 1 minus sine x equals cosine squared over 1 plus sine x. Again, not necessarily a rule, but a good place to start a lot of times in these problems is the more complicated side. So I'm going to work on the right side of this equation and try to make it equivalent to 1 minus sine of x. So the first thing I'm going to notice is I'm going to use this first Pythagorean identity to rewrite cosine squared. So cosine squared, remember, you could solve this top equation. If I subtracted sine squared from both sides, you would get cosine squared equals 1 minus sine squared. So I'm going to rewrite cosine squared as 1 minus sine squared x over 1 plus sine x. Again, try to keep your proof as vertical as possible for these problems. So the next thing that you probably want to try to do is notice that this 1 and the sine squared are both perfect squares. So this is a difference of two squares that can be factored. I believe we did a problem pretty similar to this in class the other day. So 1 minus sine squared x becomes 1 minus sine x. Erase that. Becomes 1 minus sine x. And 1 plus sine x. So I factored the top and rewrite the bottom. Again, we should see pretty quickly the 1 plus sine x is going to cancel. And we're left with just 1 minus sine x, which is what we were trying to prove. Again, start with the hardest side. Try to write things in terms of sine and cosine. There's no general rule how to work out every single one of these. They're all different, but those are a couple of tips that'll help out. So number 17. Again, a number of different ways. So if you work it out a different way, doesn't mean it's not correct. But to me, the right side jumps out at me that I can rewrite the right side. Cosine, there's nothing I can do with cosine. The only thing I can do with cosecant, it's not cosecant squared, so the only thing I can do with it is rewrite it as 1 over sine. Now this time you should know that cosecant and sine are reciprocals. So I'm going to multiply cosine over 1 times 1 over sine. And we just multiply straight across when we multiply fractions. Cosine over sine. In fact, we proved this already at the top on number 14. We proved that cosine over sine is equal to cotangent. That should be one of the identities that you're aware of. So we can write our final answer, cosine theta over sine theta equals cotangent theta. Which I guess that's not our final answer because we want it to equal 1 over tangent theta. Cotangent is the reciprocal of tangent, so we can go a step further and write it as 1 over tangent theta. So again, try to keep it vertical, try to keep it neat. Again, I would encourage you to try some of these before I work them out. You may make a mess of it, but it's kind of kind of the process you have to go through when you learn these. You're going to make a mess of them for a little while before you really get a good pattern going. And sometimes when I work them out, I make a mess of them. But this one, and again, I think we did one similar to this the other day. As I'm going to work on the left side. On the bottom, you should notice we've got a sine squared and we've got a plus cosine squared. So you look up here, that's this first identity, sine squared plus cosine squared equals 1. So I'm going to replace sine squared plus cosine squared with a 1, but we've still got a plus cotangent squared in there. And here's the tough one. I kind of feel like is the toughest to remember, that you need to sit down, maybe make flashcards, memorize this. 1 plus cotangent squared. You look up here. It's this identity right here. 1 plus cotangent squared equals cosecant squared. So we can rewrite this as cosecant x over cosecant squared x. Some of you might be able to skip a step here. Go ahead and show them all. Cosecant squared is the same thing as cosecant times itself. It's just a definition of squaring something. And then one of those cosecants will cancel, which leaves a 1 on top. And what are we trying to prove? We're trying to prove, make it equal to sine of x. Well, cosecant, 1 over cosecant x is the reciprocal of sine of x. Since those are reciprocals, 1 over cosecant is equal to sine of x, which is what we were trying to prove in the first place. So on the back, you've got a couple that are a little more challenging. But hopefully, at least you can get started on this. Write everything in terms of sine and cosine. So this is going to stay 1 over sine times cosine minus tangent sine over cosine. Get a common denominator. So notice this denominator over here has a sine and a cosine, and this one just has a cosine. So to make them the same, we need to multiply this side by sine. So we're going to get 1 over sine cosine minus, it's now sine squared at the top because sine times itself. On the bottom, and even though we've got it written in a different order, it's the same denominator. If we wanted to, we could reverse those so they look exactly the same, but it essentially is the same. So if it's the same denominator, so your tops are 1 minus sine squared over sine over cosine. Use that Pythagorean identity we've talked about so much. 1 minus sine squared is equivalent to cosine squared. One of the cosines will cancel there. One of the cosines will cancel there. So it's not a cosine squared anymore. It's just a regular cosine. And cosine over sine, that is the definition of cotangent. So let me look up. So yeah, that's what we were trying to prove. We were trying to prove that's equal to cotangent. Number 20. Gonna make number 20 and number 21 extra credit. And then we'll finish with number 22. All right, but last but not least, number 22. So one thing I noticed with 22 is that these are reciprocal functions. Cosine and secant, those are reciprocals with one another. So that means their product should be 1. The same is true about tangent and cotangent. I'm going to make this one. Well, let me work this out. This is a good example of one. So cosine multiplied by secant. Secant is 1 over cosine. So those cancel. You're left with 1. You can do the same thing on the other side. Tangent x times 1 divided by the tangent of x. Again, those are reciprocals. They're going to cancel and leave us with 1. So here's an example where we affected the left side and the right side. If you can find a way to do number 22, and there is a way to do number 22 by just affecting one side or the other, that'll be the third extra credit opportunity. So by only working on one side of the equation, that one will be extra credit, as well as number 20 and number 21. So every other problem will be graded for accuracy that I worked out on here. Make sure you have everything done from the test review ready to turn in on Friday. Again, if you've got questions, you can come in after school on Thursday, or you can come early Friday. We'll go over this.